Hello, good evening, students. लास्ट लेक्चर में हम लोगों ने गियर्स टॉपिक पर डिस्कशन किया था। आज डिस्कस करेंगे। सबसे पहला टॉपिक है आज इंटरफेरेंस इन गियर्स। इंटरफेरेंस इन गियर्स। So first of all, what is interference? Interference is the phenomenon between the two meshing gears, between the two meshing or matting teeth gears when the tip of one tooth undercuts the root of other matting tooth. So interference is the phenomenon between the two matting teeth when the tip of one tooth undercuts the root of the other matting tooth. Let us consider two gears. First one is pinion whose center is A. This gear is pinion. And second is wheel whose center of rotation is B. Base circle of the pinion is, this is the base circle of pinion. This is the pitch circle of the pinion. And this is the addendum circle of the pinion. Similarly, this is the base circle of the wheel. This is the pitch circle of the wheel, and this one is the addendum circle of the wheel. Mn is the common tangent to the base circles. This is the point P, pitch point. Point D and point C. This common tangent intersects the addendum circle of the pinion at the point C, and this common tangent intersects the addendum circle of wheel at the point D. Okay. Here, pinion gear with center A is in mesh with wheel gear with center B. The line of action will be along MN, which is the common tangent to the base circle of the two gears. The line CD is the path of contact between the two matting teeth, in which AC is the addendum circle of the pinion, addendum radius of the pinion, and BD is the addendum radius of the wheel. If pinion is driver and rotating clockwise, then the teeth on the pinion and wheel are engaged at point D, okay, and are disengaged at C. Now, if the radius of addendum circle of the pinion is increased, the point C shifts to M. The point C will coincide with the M. If the radius of addendum circle of the pinion is made equal to AM, if this radius AM is further increased, the point of contact will be the inside of the base circle of the wheel. Okay, since the since an involute can exist only outside the base circle, therefore any profile of teeth inside the base circle will of non-involute type. Okay. Hence the tip of the tooth on the pinion will then undercut the tooth on the wheel at the root and remove part of involute profile of tooth on wheel. Therefore, the interference occurs in the mating of two gears. This phenomenon, when the tip of the tooth undercuts the roots on its mating gear, is known as interference. Okay, this angle is pressure angle phi. So from right angle triangle APN, from right angle triangle APN, PN will be equal to the AP sine phi, and AP is the radius of pitch circle of pinion. So here maximum length of path of approach, maximum length of path of approach will be is equal to the Pn, which is r sine phi. And from the right angle triangle BMP, Pm will be equal to the Bp sine phi. Here Bp is the pitch circle radius of the wheel. So r sine phi, Bp Pm is equal to the r sine phi. Okay. Now maximum length of path of recess will be r sine phi, and maximum length of path of contact will be sum of maximum length of path of approach and maximum length of path of recess. So from here Mn will be equal to the Pn plus Pm, small r plus capital R sine phi. Now from here maximum length of path of recess will be is equal to the r sine phi. So maximum length of path of contact is equal to the Mn. So from here Mn will be equal to the small r plus capital R sine phi. Okay. Now solving a problem on this topic interference. Two matting gears have 50 and 13 involute teeth of module 10 mm and 20-degree pressure angle. The addendum circle the addendum is one module does the interference occur if it occurs to what value should the pressure angle be eliminated, angle be changed, angle be changed to eliminate interference. Okay. Uh, Two matting gears have 50 and 13 involute teeth of module 10 mm and 20-degree pressure angle. The addendum is one module. Does the interference occur? And if it occurs, to what value should the pressure angle be changed to eliminate interference? Okay. So first of all, given total number of teeth of wheel is 50, total number of teeth of pinion is 13, module is given 10 mm and pressure angle is given 20 degree. Addendum is equal to the one module, which is 10 mm. Okay. Let capital R is the pitch circle radius of wheel. In that case, module is equal to the d by t or 2 into r by t. So from here, radius will be equal to the module into number of teeth divided by 2. Module is 10. Number of teeth on wheel is 50 divided by 2. So radius of the pitch circle of wheel is 250 mm. Let small r is the pitch circle radius of pinion So from here small r will be is equal to small m module into number of teeth divided by 2. Module is 10, number of teeth is 13 and divided by 2 is equal to the 65 mm. Okay. Now let RA is the addendum radius of wheel. So RA will be equal to the capital R plus addendum circle radius plus addendum. This circle radius is 250 mm and addendum is 10 mm. So radius of addendum circle of the wheel is 260 mm. Let the pinion is assumed to be driver, then actual path of approach actual path of approach will be equal to the under root Ra square minus R square cos square phi minus R sin phi. Ra is 260, R is 250 and pressure angle is 20 degree minus 250 sin 20. This is 67600 minus 62500 into 0.833 minus 85.5. 111.485 minus 85.5 is equal to 25.91 mm. Now maximum length of path of approach. Maximum length of path of approach maximum length of path of approach maximum length of path of approach will be equal to r sin phi. R is 65, phi is 20 degree it is equal to 22.23 mm. As actual length of path of approach is more than the maximum permissible length of path of approach, hence interference will occur. Okay, so here interference will occur. Okay, now the interference will be eliminated if maximum permissible length of path of approach is made equal to or more than actual length of path of approach. So maximum permissible length will be equal to the actual length of path of approach. Okay, so r sine phi will be 25.91. R is 65. So sine phi is equal to the 25.91 upon 65. From here phi will be equal to the 23.49 degree. So if the pressure angle is 23.49 degree, then interference will not occur. Okay, so interference will not occur if the pressure angle is 23.49. Now the next topic is the minimum number of teeth required on pinion in order to avoid interference. Okay, let us consider two matting gears. Here the center of the pinion is Q and the center of the wheel is O, and Mn is the common tangent of base circles, and phi is the pressure angle. Okay, this is the common tangent to pitch circle. This is the pitch point P. Let radius of addendum circle of the wheel is capital R, and radius of addendum circle of pinion is small r. Let capital T is the number of teeth number of teeth on wheel. Small t is the number of teeth on pinion. Small m is equal to the module of teeth. Small d is the pitch circle diameter of pinion. Pitch circle diameter of pinion. This is the pitch circle radius of the pinion and the wheel. Pitch circle diameter of pinion is equal to small m into small t, or small r will be equal to the small m into number of teeth divided by 2. Let d will be equal to the pitch circle diameter of wheel. So capital D will be equal to the small m into number of teeth on wheel. So capital R will be equal to the small m into number of teeth divided by 2. Capital G is gear ratio. Capital G is gear ratio. Capital T upon small t, or and also equal to the capital R upon small r. And phi is the pressure angle. pressure angle. Now, the point Q is the center of pinion, whereas point O is the center of wheel, as I already told you. From triangle MPQ, what is the triangle MPQ? This is the point Q, this is the point N, this is the point Q, not Q. This is the point M, this is the point O, and this is the point P. Phi, this angle is phi. Now from the triangle MPQ. Now from this triangle, from triangle MPQ, QM square will be equal to the QP square plus PM square minus 2QP into PM into cos QPM. Okay, this angle will be equal to the pi minus 90 plus phi. This angle will be equal to the 90 plus phi. Now, here QM square will be equal to QP is the pitch circle radius of pinion. P to M is equal to the R sin phi minus 2 into R into R sin phi into cos 90 plus phi. Okay, or QM square will be equal to the R square plus R square sin square phi minus 2 small r into capital R. Cos 90 plus phi is minus sin phi, so it will be equal to the sin square phi minus plus sin square phi. Okay, or QM square will be equal to the small r square is common from the equation 1 plus capital R square sin square phi upon small r square plus 2r into r upon r square sin square phi. QM square is equal to the R square 1 plus R by R plus R by R plus 2 sin square phi. Okay, or QM will be equal to the R under root 1 plus R by R sin square phi in the bracket capital R upon small r plus 2. Now we know that small r is equal to the small m module to number of t divided by 2, and capital R will be is equal to module into total number of teeth on wheel divided by 2, and capital R upon small r is equal to capital T upon small t, or gear ratio. So from here Qm is equal to the module into number of teeth on pinion divided by 2 in the bracket under root 1 plus capital T by small t, capital T upon small t plus 2 sin square phi. Okay, now we know that the addendum of pinion will be Qm minus Qp, Qm minus small r, or Qm minus small m into small t by 2. Okay, or module into number of teeth on pinion under root 1 plus capital T upon small t bracket capital T upon small t plus 2 sin square phi minus module into number of t divided by 2. Okay, so from here small m module into number of teeth on pinion within bracket 1 plus capital T upon small t, capital T upon small t plus 2 sin square phi minus 1. Let Ap1 is equal to the addendum of pinion to avoid interference, where AP is equal to the fraction by which the standard addendum of one module for the pinion should be multiplied in order to avoid interference. So addendum of pinion will be is equal to the AP into M. Now equating the both the equations, AP into M will be equal to the small m module into number of teeth on pinion divided by 2 within bracket 1 plus capital T upon small t, capital T upon small t plus 2 sine square phi minus 1. From here AP will be is equal to number of teeth divided by 2 within bracket under root 1 plus capital T upon small t, capital T plus upon small t plus 2 sine square phi minus 1, or number of teeth on pinion will be equal to the, to avoid the interference, 2 into AP divided by under root 1 plus capital T small t plus 2 capital T small t into sine square phi minus 1. Or capital T upon small t can be equal to the gear ratio G under root 1 plus G plus 2 sine square phi minus 1. The above equation is used for finding the minimum number of teeth required on pinion to in order to avoid interference. Okay, if gear ratio is 1, which means number of teeth on the wheel and pinion are equal, then small t will be equal to the times of AP within bracket 1 plus 2 into 1 into sine square phi minus 1, or say 2 into AP divided by under root 1 plus 3 sine square phi minus 1. Okay, so the minimum number of teeth on the pinion which will mesh with any gear without interference is given as given by the above equation. Okay, in next lecture we will find the minimum number of teeth required on wheel in order to avoid interference. Thank you very much.